Hi everyone. Sorry, that might be a bit better. This is about the angle sum and difference rules from trigonometry. So the first one we're going to prove is that the cosine of alpha minus beta is cosine alpha times cosine beta plus the sine of alpha times the sine of beta. Now, in order to do that, we'll be referring to this diagram that I've prepared. This is a segment of the unit circle. I have point A here, and because the radius is 1, then, as we've seen before, the coordinate of point A is cosine of angle alpha, sine of angle alpha, where angle alpha is the angle from the positive x-axis, this green angle here, to the radius that points towards point A. Likewise, point B over here with an angle, the blue angle beta, the small angle there, cosine beta, sine beta. And importantly, I know that the triangle here, it's isosceles, so I have length of 1 and length of 1 being a unit circle. I don't know the distance between point A and B, let's label that D, and the angle at the opposite to side D would be alpha take beta. Alpha is the larger one, beta is the smaller one. That's everything we need set up ready to go. So let's find the distance between point A and B, first by applying the cosine rule. Now, you'll remember the cosine rule from a previous video, so here we go. D squared, I'll use this as the subject, would equal this side, 1 squared, plus the next side, 1 squared, minus 2 times both of those sides again, multiplied by the cosine of the included angle, which is alpha take beta. That's where I'm going to get the left-hand side of my proof. So I've got here d squared equals, let's simplify, that's 2 minus 2 cosine alpha take beta. And let's call that equation 1. We'll be coming back to that one in a little while. Now we're going to apply distance formula to do the same, to answer the same question. The question, how far is it between point A and point B? So using distance formula, we would remember that d squared equals, now it's the difference in the x coordinates. So we'd have cosine alpha take cosine beta, cosine alpha take cosine beta squared, and then it's the difference in the y coordinates, sine alpha take sine beta. Also squared. Now let's expand. So I'd have cos squared alpha minus 2 cosine alpha cosine beta plus cos squared beta. That's the expansion of the first. Now I'll have sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Let's take a little bit of a look here. I notice I have cosine squared alpha, and then over here I have plus sine squared alpha. Now that's the Pythagorean theorem, so that those two terms together would equal 1. Then I've got cosine squared beta, and over here I have plus sine squared beta. That's the Pythagorean theorem again. Now there is a common factor of -2 on these remaining two terms. So let's factorise that. Let's take that -2, and it would leave cosine alpha cosine beta plus sine alpha sine beta. Now, at the risk of annoying people, I'm just going to rub that out and replace 1 plus 1 as 2. So that's d squared. Let's call that equation 2. That's d squared. Now what did we have earlier? We had d squared was 2, that's the same, minus 2, that's the same. So this part of equation 1 corresponds, therefore it must equal, this part of equation 2. And that's what we needed to prove. We needed to prove that those two parts were the same. We just need to make that conclusion. So because equation 1 equals equation 2, they were both the same as d squared, that gives me cosine of alpha take beta equaled cosine alpha cosine beta plus sine alpha sine beta. And that's our first formula. Now we're going to keep going here. Imagine please that I had the following. Cosine of alpha plus beta. Well, I could write this as cosine of alpha subtract negative beta. And I can now apply the rule that I just used because I've got an angle take a different angle. So using the rule, I have cosine alpha cosine of the second angle, negative beta, plus sine of alpha sine of negative beta. And if we remember the CAST rule, the old cast rule, negative beta down here in this quadrant, the cosine of negative beta is the same as cosine of beta. But the sine of a negative angle is negative. So we'd have, that's my second rule. There's cosine of alpha plus beta. So I have the sum or the difference of two angles. And if I've taken the cosine of a sum or a difference, I have these formulas as the appropriate. Now, you may be wondering about sine. Let's try sine. Oops, still in red. Let's try, come on Biro, you can do your thing. Let's try the sine of, which one will we do first? Alpha plus beta. Now I'm going to use the cosine. Remember, cosine literally means the sine of the complementary angle. So I could have 90 minus alpha. I probably should have a little pair of brackets around the alpha plus beta there. It's all right. Now I'm going to reorder this as 90 minus alpha minus beta. And I'll be thinking of this first pair as my initial angle, subtract a second angle, beta. Now, isn't that a rule we already had? Didn't we already have a rule for cosine of one angle, take another angle? Yes, we did. It was this one. Let's make the necessary replacements. So it's cosine of the first angle by cosine of the second angle plus sine of the first angle by sine of the second angle. Now 90 minus alpha, the complement of that is alpha, and so I'm really talking here about sine of alpha. Cosine of beta doesn't have to change. And where I have sine of 90 minus alpha, that's more easily expressed as the cosine of alpha by the sine of beta. So what did all that start life as? That started life as the sine of alpha plus beta. Let's write that one down as a rule. The sine of alpha plus beta equals sine of alpha cosine of beta plus cosine of alpha sine of beta. There's a third rule, which is very handy. Now the last one would be for the sine of a difference between two angles. So we would go sine of alpha take beta. And we would note that that is the same as the sine of alpha plus negative beta. So I'm going to apply my previous rule about the sum of two angles. My rule goes the sine of the first by the cosine of the second plus the cosine of the first one multiplied by the sine of the second angle. Once again, let's remember CAST rule. For our negative angle beta, the cosine of negative beta is the same as cosine beta. So this is sine alpha cosine beta, but the sine of a negative angle is negative. Cosine alpha sine beta. And this one was the difference of two angles, the sine of a difference. There we are. We have just done in, or a little over 10 minutes, a proof of the angle, sum and difference formulas. So sine of alpha plus beta, or the sine of alpha take beta. Then these ones up here, the cosine, whether it was alpha plus or alpha minus. So that's a quick run through of the angle, sum and difference formulas.